Hello student, this video lecture is prepared for heat transfer subject for diploma students, and I will discuss the unit number 6, that is evaporation. In the last lecture I had discussed there are two types of evaporators. One is natural circulation and then forced circulation, and from that we will discuss the different types of evaporators one by one, construction and working. In that we will discuss first open pan evaporator, which is also called a jacketed pan evaporator. Next one is the horizontal tube evaporator. Then next one is the calandria type, which is also called a standard vertical tube evaporator. And again which is also called a short tube evaporator. And if the time permit, we will discuss the long tube vertical evaporator. So let us start the lecture. So this is the open pan evaporator, which is also called a jacketed pan evaporator. So it is a simplest method for concentrating the solution by using jacketed pan. So the pan, that means this part, is made from the stainless steel, copper or aluminum, and generally it is used for small scale production and food process industries. And there is jacket, so this part is called a jacket. That jacket is welded to this pan. So this part is called a pan and this is the jacket. So why the jacket is made? To provide the steam inlet. That means for heating purpose this jacket is made. And you have to feed the material from this point. Okay, that means this part is open and you have to admit the steam in this jacket. So the evaporation is taking place with your given determined time, or you can predetermine the time, and after achieving the desired concentration, that means suppose if you put the 5% solution and if you want to 20%, then when the 20% thick liquor is obtained here, then this thick liquor can be withdrawn from the bottom. So this is the simplest type of the evaporator, and it is used for the small scale production and food process. So here I will show the lab model. So here this is the small pan and the steam is created here by using water, and then steam is passing through this jacket. So this part is called jacket, and after you get desired concentration, you can take out the thick liquor from here. So this is called a open pan or jacketed pan evaporator. The next is the horizontal tube evaporator. So it consists of vertical cylindrical shell. So this is the vertical cylindrical shell incorporating a horizontal square tube bundle at the lower portion of the shell. So these are called a tube bundle, which is having square tubes. That means shape of that tubes is square, and these are incorporated at the bottom of this cylindrical shell. The channel is provided on the both ends. So this is called a channel. So channel is provided on the both end of the tube bundle for the introduction of steam. So steam is introduced from these tubes, and the shell is closed by dished head. So these are the dished head at both ends. So this is the top end, this is the bottom end. The vapor outlet is provided at the top of the cover. So this is the vapor outlet which remove the solvent evaporated, and the thick liquor outlet. So this is the thick liquor outlet is provided at the bottom of this cylindrical shell. So in this evaporator, the feed is admitted from here. That means dilute slurry or weak liquor, weak solution is admitted from here, and the steam is admitted from here. So heat is given by condensing the steam and the solution get evaporated and the solution boil and the vapors form are removed from the top while the thick liquor which is removed from the bottom. So here the small diameters of the tubes are used in a horizontal tube evaporator. So what is the main advantage? Low headroom requirement. That means this is called a headroom. So this is height or low head is required. Then larger vapor liquid disengaging area. So this is called a vapor liquid disengaging area. That means the vapors are free from this solution. So this is called a disengaging area. So vapor is separated from here. So this area is very large as compared to the other evaporators. And what is the limitation of this evaporator? It is not suitable for salting and scaling liquids as it deposits on the outside of the tube. So I already discussed that salting and scaling liquids, that means scale and salt is deposited on these tubes, which will decrease the heat transfer rate. Therefore, this type of evaporator is not useful for scaling liquids and salt liquids. And what is the application? These type of evaporators are generally used for small capacities, simple problem of concentration, such as industrial syrups. Syrups are generally made in a food industry, chemical industry, pharmaceutical industry. So that syrups can be made in this horizontal tube evaporator. Then the next type of the evaporator is calandria type, or it is also called a standard vertical tube evaporator, or it is also called a short tube evaporator. So vertical tube means the tubes are vertical. So in previous case the tubes are horizontal. So you remember in this way, if the evaporator is called horizontal tube, that means the tubes are horizontal, and when the evaporator is called vertical tube, that means the tubes is vertical. So the construction of both the evaporator is same. It consists of cylindrical shell. So this is the cylindrical shell incorporating a short vertical tube bundle with horizontal tube sheet bolted at the shell flange. So this is that tube bundle which is incorporated at the lower portion. The vapor outlet is provided at the top of the cover. So this is the top cover. The vapor outlet is provided here. The thick liquor is discharged. That means thick solution is discharged from the bottom. And the tube bundle is having the height up to 150 centimeter, and the tube diameter should not be more than 75 millimeter. So these are the limitations for these evaporators. And there is a downtake is provided at the center of the tube bundle with flow area about 40 to 100% of the total cross-sectional area of the tube. So downtake is nothing but the pipe which is having the more diameter, that is called a downtake. I will show the figure in next slide. So this is called a downtake. So what is the flow area in this downtake? 40 to 100% of the total cross-sectional area. So this is the suppose total cross-sectional area. Then out of that 40 to 100% cross-sectional area is maintained in this downtake. And why this downtake is provided? For circulating the cooler liquid back to the bottom of the tubes. So circulation is taking place from this area, then again it will increase here. So in this way the circulation, natural circulation is taking place in this calandria type or standard vertical tube evaporators. Then the steam is distributed outside the tubes. So steam is distributed through outside the tubes, and the condensate, that means after giving this heat, steam will convert it into condensation. So that condensation will be taken out from here. And non-condensable gases, that means sometimes there may be non-condensable gases present in a steam, that will be vented from here. So air vent is provided here. And this is the vapor disengaging space, that means vapors is removed from the top. So here I will show this figure. So this is called a downtake, and these are the tubes. So this is the actually top view of the tube bundle, that means this part. This part is shown in this photograph, or you can say seen from here, or you can look here. So this part is called a downtake. So this is provided for the circulation, and these are the tubes which is having smaller diameter. So in working, you have to add the feed from here and the steam from here. Then this feed liquor cover the top of the tubes, and heat transfer is taking place by condensing steam. The vapors are formed is removed from the vapor outlet provided here, and then the concentrated liquor, that means thick liquor, is taken out from here. Then what are the advantages of this evaporator? It is relatively inexpensive, that means cost is less. Scaling occurs inside the tube, so there is, you can use for this evaporator for scaling liquids. It provides good heat transfer rate. It is having high heat transfer coefficient. It requires low headroom, that means vertical space is required low. And what are the disadvantages? Floor space is required more, because this evaporator is having vertical tubes, so this floor space is higher. Amount of liquid hold up in evaporator is large, so the tubes material, that means feed material, is having, that is hold up, is large in this evaporator, and it is not suitable for viscous liquids since the circulation is poor in this case. So the circulation is poor, therefore it is not suitable for viscous liquids. So here we have discussed 3 evaporators. First one is the open pan evaporator, construction and working. Then horizontal tube evaporator, and at the end of lecture I had discussed calendar type evaporator, construction, working, advantage and disadvantages. So here I want to conclude my lecture, and the remaining part of the evaporator we will discuss in the next lecture. Thank you.